Hey, what is going on, guys, and welcome back. And in this video, we're going to start section 1 of part 6, and we're going to be learning about reading files. Now, part 6 is all about reading and writing the files, how to handle errors, and about variable scoping. So, all very useful, very interesting topics. We're going to start with section 1 on reading files, and this is one of those things that are good to know in programming. If you were to take a college course, perhaps in Java or C++, you're gonna cover this pretty early on in the course. Um, but yeah, being able to have your program find a file, open the file, read the contents of the file, and be able to either save the content into your program or scan through them and do something with the details that your program is consuming that is coming from the file. So pretty useful thing to be able to do and to learn how to do. And we're going to go through the material and learn how to do that together. So the learning objectives in this reading file section is that you will know how to read the contents of files with Python. You'll know what a text file and a CSV file are. CSV stands for comma separated values, and we'll see what that looks like down in this when we're reading the material. And you'll be able to process the contents of a CSV file in your programs. Okay, about the exercises on this course. Becoming a proficient programmer requires a lot of practice, sometimes even quite mechanical practice. It also involves developing problem-solving skills and applying intuition. This is why there are a lot of exercises of different kinds on this course. Some of them ask you to quite straightforwardly apply what you have learned in the material, but some of them are intentionally more challenging and open-ended. And again, this is a commonly recurring theme as we've gone across the content and material of the course so far. Even some of the exercises in the previous section in part 5 had some challenging exercises that were pretty open-ended that didn't really tell you whether you should use what you just recently learned to do things. And again, as part of my goal is to try to use recently learned material in the exercises as much as I can. And so I'll continue to try and do that, but this is something that you should be aware of when you're, in the world of programming, that a lot of the challenges that you're gonna face in the real world, there's a hundred different ways you could solve that issue. So programming by nature is a very open-ended experience. And so that's what we're also learning and picking up from doing this course together. Some of the exercises might at first seem overwhelming, but this is nothing to worry about. None of the exercises is strictly mandatory, and in fact, only 25% of the points in each part is required to pass the course. So we've seen this entire message before. Every time you start a new chapter or a new part, you see this message, right? This is just them reiterating the fact that you don't have to do every exercise. You only have to do 25% of the points in each part to be required to pass the course. So, you don't have to go through every single exercise, but for us, it's good practice, especially if you have intentions of pursuing a career as a programmer, or as a software developer, or an engineer. And Python might be your specialty or something you want to focus on. So that's why we go through every exercise. But you as an individual doing this course on your own, not following along with what I'm doing or what we're doing in this playlist, you don't have to do every single exercise. You can just do the ones that you're capable of. You can easily go through and understand the requirements and and pass each test and submit them. But you only have to do 25% of the course or the material in the course to pass it. So um, the exercises are not in any specific order of difficulty. Each section usually introduces some new programming concepts, and these are then practiced with both simpler and more complicated exercises. If you come across an exercise that feels too difficult, move on to the next one. You can always come back to the more difficult exercises if you have time later. When the going inevitably gets tough, a word of consolation, a task that seems impossibly difficult this week will likely feel rather easy in about 4 weeks' time. Again, if you have the luxury of time, right? If you can take this course on your own accord and at your own pace, and you can go and come back as you please, and yeah, a couple of weeks after you encounter a difficult challenge, you can come back to it and see if you can actually take on that challenge. But we're pressed for time. We want to get through this course as quickly as we can. So we'll just have to keep toughing it out. That's why I usually not even our goal is to go through entire sections in one video, but as you've seen from the previous videos so far, I've been cutting them up again. Just maybe in one video I'll go through half of the section. In another video, I'll dedicate specifically to an exercise that I think is very challenging, that deserves its own exercise, which gives me time to think about the exercise and build a mental model of how I want to approach it so that I can do that on video for you guys. So don't whenever you encounter a difficult challenge or a difficult exercise, don't despair. Don't lose hope that you're not a good programmer or you don't know what you're doing, or right. It's gonna feed into that imposter syndrome, which is something you're going to go through a lot when you do get a job in software engineering, that you feel like you don't belong or you're not good enough or you're not smart enough, et cetera, et cetera. Um, just give yourself some grace, give yourself the time, right? Sometimes just break down the problems piece by piece and see what pieces you can get done, and then leave the more challenging parts for later, and then come back to those more challenging parts and take them on, right? But continue to break down things to the simplest uh, possible, you know, line of code that you can write, and then you build on from there, right? Just build in chunks and continue to build in chunks, and eventually you just be able to overcome these challenges. All right, a very common use case for programming is handling data stored in files. Programs can read data from files and write the computer results to files. Even large amounts of data become easy to process automatically when files are used. On this course, we only deal with text files. All the files used will consist of lines of text. As an example, the Visual Studio Code editor we use on this course works with text files. Even though word processors such as Microsoft Word are usually used with files that contain text, Word documents themselves aren't text files. They also contain formatting information and are encoded in a way that makes handling them in a program more complicated. So yeah, I mean, Microsoft Word files are a little bit trickier to work with because they have details on custom formatting, um, have a bunch of other details. As you can see, maybe if you open like a Word document, you will see that you have gutters on the left and right side of the document, right, with margins of where you can start writing your text and where the software will start wrapping your sentences over and things of that nature. But a text file in programming that you always want to work with is a file that ends in .txt, which stands for text. All right, so reading data from a file. Let's first work with a file called example.txt, which with the following contents. So the file example.txt has 3 lines. First line is hello there. Second line, this example file contains 3 lines of text. And the final line, this is the last line. A simple way to include files in a Python program is to use the with statement. The header line opens the file, and the block where the file can be accessed follows. After the block, the file is automatically closed and can no longer be accessed. So the following code opens the file, reads the contents, prints them out, and then closes the file. So the format looks pretty similar to how you would, for example, declare an if statement or a function, right? We're not using the exact same keywords, especially the reserved keywords like with and open and as, but the structure is very similar to how we write other types of code blocks in Python. And remember your colon, and then everything that you want to be done from the file, right, is nested a little bit inside of the head of this line that tells Python to open a specific file for us. So this code says with open, and we pass the example.txt file name as new file. So this is how we're going to be referencing the file in our code. Then we say contents, we declare a variable here called contents, set that equal to new file dot read. So the dot read method is available to our files. And then we can print contents. So Python will scan the file, right? And then we reference what all the contents that's been read to this variable contents, and then we can print contents. And then when we run our program, this is what it's going to do. It's going to print back what's in the file. The variable new file above is a file handle. Through it, the file can accessed while it is still open. Here we use the method read, which returns the contents of the file as a single string. So in this case, the string returned by read will be this, right? So it parses new line characters and it puts them in that in our string. So it adds new line breaks where they existed in the original file. So we see hello there, followed by an exclamation point, and then there's a new line character here. There's one right here, and then there's no more over there. So that's why we see this backwards /n, right, added into our string. Going to the contents of a file. The read method is useful for printing out the contents of the entire file, but more often, we will want to go through the file line by line. Text files can be thought of as a list of strings, each string representing a single line in the file. We can go through the list with a for loop. The following example reads our example file using a for loop, removes the line breaks from the end of each line, counts the number of lines, and prints each line with its line number. It also keeps track of the length of the lines. So again, with open, we give it the file name, and then we declare a reference of it being called new file. We declare a new variable here called count, set that equal to 0. Total length, set that also equal to 0. And then we say for line in new file, line is equal to line.replace. So we find everywhere that has a carriage return or the new line character, and we replace that with empty strings. And then we increment count by 1. We print the line and the count, and then we print the length of the line. We get the length of the line, and then we increment total length by the length that we accrue, right? That we get from each line, and then we print total length of lines is total length. So I realize as I'm saying this that it might even be a little bit easier to see this in action. So I'm going to create a file here called example.txt, and I'm just going to copy this code. I'm going to paste it in here. Oops, I'm sorry. I meant to paste it in here. And I'm going to copy the body of the file, the example file, and paste it in the example file. So now you can see. Now part of the reason why you co-locate whatever file that you want to work with next to where your program is going to be written in is that it makes it easier to find it. So you don't have to worry about changing directories and whatnot. So when I run this code, you'll see that it's going to print. Oh, we're getting an error. Okay, there it is. So the issue was we didn't change, because we're running this manually. We didn't change directory into this into the source folder. So we just do change directory into the source folder, and now when I run this, you can see that it prints line 1, hello there. Line 2, this example file contains 3 lines of text. Line 3, this is the last line, and then the total length of lines is 81. So this is what our code is doing here. So another way you can look at it is, let's say for example, we don't want to worry about the count, we don't want to worry about the length, we don't want to worry about total length, right? So I'm just gonna comment this out. We just want to go through the file, our example.txt file, and print each line on its own line. And there we go, we get line hello there. And then creates a new line print statement, and then it prints a new one, and then it prints the final line here. So that's basically, the simplest way to demonstrate working with files, right? How to read a file and how to print the contents of a file. We can print them through a loop like this, or we can save the contents of it to a variable and then print the variable itself, right? As we saw earlier, we can use contents is equal to new file.read and then print content, right? Like that. Now let me clear this and run our code. And there we go, it prints hello there. This example file contains 2 lines of text, and this is the last line, which is exactly what's in here. And if you remember, right, the way that this string will be stored will be similar to if we were to do this. Print this, but everywhere where a new line break occurred, we put the new line character. So these two will print the exact same thing. So in fact, if I put an empty print here, and then run our code, there you go, they print the exact same thing. So that's what it's doing, right? It's reading the contents, and it's also parsing the new line breaks, right? into these new line characters that look like this. And then when he prints, that's why everything still is formatted the exact same way. All right. The variable new file above is a file handle. Do it the file. Oh, I'm sorry, we've seen this. There is a line break at the end of each line in the file, but the print function also adds a line break by default. There are no extra line breaks, right? And if you're worried about this, that's what happens. The print function adds a line break to the end of it by default. So even if we were to replace it with an empty string, Python will still put a new line break because of the default behavior of the print function. There are no extra line breaks in the printout above because the line breaks at the end of the lines are removed with a replace method. It replaces each line break character with an empty string. This way, the lengths of the lines are also calculated correctly. Okay, we have our first exercise of the section called largest number. The file numbers.txt contains integer numbers, one number per line. The contents could look like this: 2, 45, 108, 3 minus 10, 1100, etc. Please write a function named largest, which reads the file and returns the largest number in the file. Notice that the function does not take any arguments. The file you are working with is always named numbers.txt. Okay, so if we go back to VS Code, clear everything that we wrote here, and delete this file. We don't need this anymore. That's just for an example earlier. Take a look at the numbers file, and whoa, it's a lot of numbers here, right? Some of them are negative numbers, some of them are positive numbers, many of them are positive numbers. Some are 4 digits, some are 3 digits, some are 1 digits, some are 2 digits, right? It's just a bunch of numbers. We don't need to worry about the details. So what we're supposed to do is write a function named largest, which reads the file and returns the largest number in the file. Okay, so define a function called largest. Doesn't take any arguments, but it does return, which reads the file and returns an integer. So next we're going to say with open numbers.txt as file, and then we're going to say, we're going to declare a variable here called largest num, so that equal to 0. And down here we can return largest sum. Then we're going to say for line in file, if line is greater than largest num, set largest num equal to the integer conversion of line. The instructions didn't really discuss whether or not numbers will be interpreted immediately as integers or whether we have to typecast them. So I'm just doing that just in case. Oh, I said largest num, not largest sum. Okay, so say we run this, see what happens. Or we have to actually be able to test this. So let's print largest. Right, whatever it returns. Okay, it returns 9988. So let's find 9988. Is it the largest number in here? So far, it seems like it is. Right, we have to manually verify this. 958, nope, we're looking for 99. Any other 99? There's only one number that comes up with 2 99s. That is positive. So, I'm sorry, 5 numbers. So that's all the other ones are negative. All the other ones are negative. So this 9988, which is the first number, is the largest number. So we should run this through our test and see how we do. Okay, we failed one thing. It says code testing must be okay, right, so we need to get rid of that. There we go. Send the solution to the server. Show model solution in the browser. Right, so they did pretty much similar to what we did. They opened the file, set start to true, biggest, set that equal to 0. For number in file, if start or integer number is greater than biggest, set that to biggest. Otherwise, set start to false. So I'm not, no, they're using a loop for whatever reason, but they're structuring like this. Now I'm curious. Let's let's put this solution here and see what it returns. Does it also return 9988? Okay, so it also does. So yeah, so this is my solution, or our solution. I should. Oh, whoops, actually, wrong solution. There we go. This is our solution. Pretty short, pretty straightforward. This is their solution. I'm not sure exactly why they have a start and start helper variable. If start or because there's really no way to manually change what start is. So start is equal to true if start or integer number is greater than biggest, then right. Everything here makes sense, but the use of the start variable, because if start equals false, does it kick us out of the if statement here? I don't really get it, but this is us again. We did the wise thing of typecasting, right? Integer for every line, so it seems that Python doesn't interpret each line, even if it contains a number, as a integer. It interprets it as a string, so we typecast the line. In fact, it actually makes more sense to change this to use number as the argument instead of line. So number in file, typecast it, and then we set that equal to the largest number that we're tracking of, and then return that largest number. So you can, again, if you would like, submit your second solution. Again, send that to the server. You're going to pass, because you already passed the first time. You just want to have the second version of it. You can access it on the TMC website. But again, if you want to test, let's see, for example, maybe this is just a fluke. Let's get rid of 9998, right? And then let's run our code one more time and see what happens. I'm going to close this, and I'm just going to do Python largest number.py. Oh, right, we got to actually call the print function and start. And there we go. We get 9883, which is the next largest number somewhere here, 9883. It comes up, it's the fourth number actually on the list, right? So you can see that it actually does work. It does actually read the file and then, find the largest number. In fact, if we were to move the largest number to the bottom of the file, for example, maybe somewhere towards the bottom, and then run the code one more time, and there we go. It still gives you 9988. So yeah, that's the solution to this exercise. If you go back to the course website, refresh, make sure you get points for that, and we'll keep it going. All right, what if Visual Studio Code cannot find my file? When you execute your code, Visual Studio Code might complain about not finding the file, even though you have checked and double-checked the file name was written correctly and the file exists. Changing the following setting may fix the problem. So we didn't have that problem on video, but if you're having that issue, you might benefit from reading this a little bit more. I'm still gonna read through it, but you might just have to take a little bit of time to read through the what's going on over here and update these settings on your instance of VS Code. So open the settings from the menu bar. So I'll demonstrate that. Right, File and Preferences and Settings. Like that. Find the relevant setting with the search term Execute in File. So you can just paste that in there, and it's going to show up the Python extension file. And then you can check it, right? Choose the tab Workspace. Select the option under Python terminal, execute file in file directory. Right, this one, you can check it. Your settings window will now look something like this. So if you check it, it will look like this. If this doesn't help, you can copy the file in the source directory, directly the root of the exercise directory. Yep, which is what I had to do when I was showing you guys the example earlier in the video. So yeah, you might just have to move the file over somewhere. Maybe the file might be sitting in the top level folder instead of it being inside the source folder, so you just have to move it over. But for even in these exercises, they already have them located in the source folders for each exercise, as I'll show you here as well. So this probably won't be something you have to worry about. But that was the mistake that I made earlier. I just clicked on the folder here and created a new file, but it was sitting outside of the source directory. So I just had to move. I was outside of the source directory, so I have to move in here to find the file and then run my program. So yeah, just you might have to relocate where the file is, or if not, update the setting with these instructions. Again, I'll show you how to get to this part. Again, File, Preferences, Settings, and then write and execute in File as one word. Click on Workspace. Don't change it for your user, just change it for the workspace. So every single time the TMC, when you open VS Code and you open the TMC workspace, this setting will be enabled for you. So again, I don't have that issue of Python not being able to find whatever file that I'm referencing in my programs so far. So if that problem does come up, then I'll probably activate that. But for now, everything seems to be working accordingly. So make sure you just check that little box, and you should be good to go. Okay, debugging code which handles files. All right, using Visual Studio Code Debugger with programs which handle files will often result in a nasty looking error message. So can I open this image up? Right, so here we go. The reason that the debugger will always look for files in the root of the exercise directory. The execute in file directory setting mentioned above will have no effect on this. The easiest solution is to just copy the file to the root of the directory. You may need to restart Visual Studio Code after copying all the necessary files. So you see something like this, right? No such file, file not found error, or the exception. So even if you have it in, so say for example, you're working with this file called fruits.csv, and you use the VS Code debugger. So you can activate it by pasting steps here, and then to add a breakpoint to your code, and then go down here in the debug console. Right, and then you can use the debugger, etc., etc. But when you do that, the debugger doesn't have access to your files, so it won't know, right? So if you guys remember this, we went through this in the very first video after we installed VS Code. So wherever you create your breakpoints, etc., etc., if you open a file in your program, then the debugger doesn't have access to it, so it doesn't know what file you're talking about if it's located inside the source directory. So you might have to move it up, right? Copy the file and move it up to the exercise folder, and that's where it might be able to find it. So if you encounter that error when you're if you do rely on the debugger, you might come across this file not found error, and this is what you can do to fix that. Just move the file to the root of the exercise directory. So it could be either the file needs to be moved up or moved down. If it's not moved in the source folder, you might need to move it into the source folder or vice versa. But the solution will probably be that you have to relocate that folder. So you just have to play around with it and see what where in the directory the debugger will be happy reading the file from. Okay, reading CSV files. Oh, before I forget, did I stop the debugger? Yeah, I did. Okay. A CSV file, short for comma separated values, is a text file which contains data separated by a predetermined character. The most common characters used for this purpose are the comma and the semicolon, but any character is, in principle, possible. CSV files are commonly used to store records of different kinds. Many database and spreadsheet programs, such as Excel, can import and export data in CSV format, which makes data exchange between different systems easy. We already learned we can go through the lines in a file with a for loop, but how can we separate the different fields on a single line? Python has a string method split for just this purpose, and we've seen this in the past, right? You can split a string, for example, if it has spaces, you can, better to demonstrate than to just yap, so we'll just go to the Python playground. So here we have a string called text, which has, the variable text, which is referencing this string with the words monkey, banana, harpsichord with comma separations, right? Comma separating each word. So now here we have words, and we do text that split, and we split by comma. So what this is going to return, in fact, I think will be very useful for us to print words, so you can see what this does, what using text that split does. It's going to return a list with all these words. There you go. So now, right, we have the text, has words separated by commas. We save whatever's returned from doing text.split, right? And we specify the comma as the character that we want to split our string with. And then words is now pointing to a list that contains all our words in this list. And then we can loop through the list like this. And it doesn't have to be commas. It can be a space, and we'll do the same thing, right? And we still get those words. So the split function, split method that works with the string class, right? The string objects, will go through a string and parse it in a way that gives us back certain values in a list, and then we can iterate through that list using a for loop. So this is what happens when we split the text into words, right? Returns that list, and then that list we can loop through it and print each word individually. Let's assume we have a file, grades.csv, which contains names of students and the grades they received on some courses. Each line has the data of a single student, and the data is separated by a semicolon. So we have lines with a student name, then each value after the semicolon is a grade. So 5, followed by another semicolon, 4, followed by another semicolon, 5, 3, etc., etc. And we have the same thing for these two other students, Beth and Ruth. The following program goes through the file line by line, splits each line into its separate parts, and prints out the name and grades of each student. So we open the file, then for each line in the file, right, we get line. We take our line and we replace any carriage breaks with any new line characters with empty strings. Then we get each part from the line. So we do line.split, and we split by semicolons. And then because we know that the content is always the same per student, so we know that the first thing in the line, right, the first thing that will be stored in our parts list once we split our line will be the name. So we can set name equal to parts, and then we can set grades equal to everything after the name in the list. So now when we print the name, it'll print like this. We'll print Paul, and then when we print grades, it'll print the remaining of the grades. So I think that's pretty simple. So we're gonna test that and see what we've learned in this next exercise called Fruit Market. The file fruits.csv contains the names of fruits and their prices in the format specified in this example. Fruit name followed by the price. So banana, semicolon, price. Apple, semicolon, price. Orange, semicolon, price. So we can imagine that this goes on for quite a few lines. We're told to please write a function named readFruits, which reads the file and returns a dictionary based on the contents. In the dictionary, the name of the fruit should be the key, and the value should be its price. Prices should be of type float. The function does not take any arguments. The file you are working with is always named fruits.csv. So this is fruits.csv, has 8 fruits in there. Each fruit has its own name and its price, and it's separated by the semicolons. So we're told to write a function named, what is it called? Read fruits. Takes no arguments, but does return a dictionary. So we'll declare a dictionary here called fruits. So that equal to an empty dictionary, and then we'll return fruits at the end of our code. I wrote this wrong. There we go. That fixes that. Then we're going to say with open fruits.csv as file. I'm going to say for line in file. Then we're going to say line is equal to line.replace with empty strings. Then we're going to say parts is equal to line.split like that. Then we're going to say fruit name is equal to parts 0. Fruit price is equal to parts 1. Then we can say fruits at fruit name is equal to fruit price. In fact, we're just using fruit way too many times. So we can even just change fruit name to just be name. Okay, so now we can test this by printing read fruits and see if our code works. Uh-oh, it's crap. It's gonna run the debugger. Right, this is the error. No such file found. Right, because I'm running the debugger. I need to just run the Python file. Okay, okay, we can stop that. Run Python file. Clear this. Run the file. Okay, we're getting a problem. No such file. Okay, so that's weird. Am I misspelling something? Oh, again, same issue. I need to go into the source folder. Thought it would automatically, because normally it would automatically change my directory into the source folder. Okay, now we should be able to be okay. There we go. Now we get our dictionary back that has the fruit name as the key and the fruit price as the value. So if I was to say, for example, fruits is equal to read fruits, then I say print fruits at banana, right? If I knew what the contents of this dictionary were, then I'll get 650 back, right? Because 650 is the value that is mapped to the key banana in our dictionary. So we know our code works. We can go ahead and run our tests. Oh, we failed. Your function should return banana, apple, pineapple, mango, orange, and pomegranate. But it returns banana. Oh, it's saving them as strings, not floats. Oops, sorry. So we need to typecast this float, which was explained in the instructions, but I was getting ahead of myself. Okay, so again, let's just test this. Read fruits. See if we get the right values printed. There we go. So now no more strings as keys, as values. We get these floating point numbers. So this now should work if we run I'm sorry, it's going to fail because of this. Now let's test our code and we should pass. There we go. Send that solution to the server. Show the model solution in the browser. And yep, they did the same thing. They didn't get rid of the new line character like we did, right? So this isn't necessary. So this will still work. Again, if we test this, if we just run our tests, it should also work. So we don't need to really do that, but it's whatever. We can submit that second solution. But yeah, our solutions are completely identical, right? This is the only thing that I guess is kind of weird because again, with scoping and Python, it's still a little wonky even for me. But they declare the fruits dictionary inside of where the file is opened, but they return it outside of it. So this might be just a little, but this is just better practice, I think. Just declare it outside of where you open your file, and then wait, what just happened here? Fruits name. Oh, okay, never mind. Right. So they declare it here, but again, they loop through the file, extract each line by splitting the line, and then setting the dictionary to the value. So you can even, if you want to be even a little bit more streamlined, right? You can say fruits parts 0, that will be the name, and then we know fruits part 1 will be the price. So I'm sorry, parts will be the name. So you can even just get rid of these and just keep it like that, and this will also work. So if we run our tests here as well, never mind, read fruits, make sure the function can be called. Oh, that's interesting that this didn't work, but the other one, but does work. Did I forget something here? Okay, so it still works. So I might have either was missing some brackets somewhere or something, but this now should work. So if we can get rid of these, right, our function, I mean, our what we do after we open our file inside the for loop, it shrinks even further. Um, there we go. So all the tests passed. So yeah, this could even be your solution, right? It could be as short as 9 lines, and it will still work. So I even like this, but for our sake, and this is the solution I'm going to save on the repository. Um, I will go with just extracting the values. So name will be parts 0, price will be that, and then down here we can just say fruits name is equal to price. And again, if we run our code, it's still going to work. So yeah, so that's the solution to this exercise. Refresh, we got our points. Here we have another exercise called matrix. The file matrix.txt contains a matrix in the format specified in the example below. So this and this and this, and it goes on. In fact, we can actually open it. In the third exercise here, sorry, matrix.txt. Okay, this is our matrix. These are two functions named matrix sum and matrix max. Both go through the matrix in the file and then return the sum of the elements or the element with the greatest value, as the names of the function imply. Please also write the function row sums, which returns a list containing the sum of each row in the matrix. For example, calling row sums when the matrix in the field is defined as 1, 2, 3, 2, 3, 4, the function should return the list 6 and 9. You can also include other helper functions in your program. It is very worthwhile to spend a moment considering which functionalities are shared by the 3 functions you are asked to write. Notice that the 3 functions named above do not take any arguments, but any helper functions you write may take arguments. The file you are working with is always named matrix.txt. So we need to write a function that both go through the file, we go through the matrix, and then return the sum of the elements or the element with the greatest value, as the names of the function imply, the sum of the elements. So I'm assuming he wants us to go through this and add up all the values in the matrix. So that would be matrix sum, and matrix max will be just go through this and find the largest value. And then we need row sums, which will return a list containing the sum of each row. So horizontally, so 1, 2, 3, 4. Okay. So it seems a bit challenging, but I think we can get through this. We're about 43 minutes into this reading, so I think this exercise should take us into the 50-minute mark. And there's a lot of readings between us and the next exercise, set of exercises in here. So we might break this into 3 videos, to be quite honest with you. But let's see how we do with this exercise. So we're told to define 3 functions. The first function is called matrix sum. The second function is called matrix max. And the third function is called row sum, right? Row sums. Okay, so this one returns a list. This one returns an integer, and same as this one. So, okay. First thing we need to do is create a variable called sum, set that equal to 0. Then we open the file with open matrix.txt as file. Then we need to get each line. So for line in file, line is equal to line.split and split by values, I mean by commas. Then we're going to say for number in line, sum plus equals number, and then we return sum. Oh, I'm sorry. We have to typecast this. That's why it's giving me that error. So we can do plus because each thing is not going to be uh, an integer like that. So now this works. So now this returns matrix sum. So let's print matrix sum and see how this does. I'm just gonna manually navigate to part 0603 underscore matrix source. There we go. Then I'm going to run this file, see what happens. Okay, matrix sum. Okay, we're not in the source directory as I thought I was. Now let's run it. There we go. 4542 is the sum. So, I mean, there's not a way for me to verify that without, actually, let me find a website that can edit. Okay, so I went to, what website is this? Right, this free online delimiter tool called delim.co. It's a comma delimiter. I pasted in all the contents from the matrix file, just Control A, Control C, Control V. Then run it through. So it gives me back this one singular line. Then go to calculatorsoup.com, paste that in, hit calculate, and we get sum is equal to 4542. And what did our function give us? 4542. So we are 141. Now this function is called matrix max, and it's supposed to go through the file and find the largest number. So where are we? Right. So go through the matrix and find the largest number. So we're just going to do the exact same thing here. I'm just going to copy the body of this, paste it here, change sum to largest, set largest equal to the integer of this number. So I will say if number greater than largest, actually we should do number is equal to integer number, then if number greater than largest, largest is equal to number, like that. And let's run this function and see what it gets. Matrix max, clear this. In fact, we should probably do something like this just so we can differentiate. Matrix sum, and then matrix max. Now when we run this, oops, sorry, I meant to actually call the functions. Wrap those in that, run, there we go. Matrix sum is 4542 and the largest is 965. So when we write 965, it shows up twice. So it's probably returning the first instance of it that it sees. Maybe even actually no, it will probably most likely be this one because it's going to go through each line and each number individually. So it's returning this one. So 965 is the largest number that we see here. Let's see if calculator soup can do that for us too. Maybe if it just does sum. But yeah, I'm just going to trust my function works exactly as I intended it to. Okay, now we are defining our final function, which is called row sums. And row sums is supposed to go through the matrix and for each row, add up the values and then add those to a list and then return that list. So we know we're going to sums is equal to an empty list. Then we're going to have to do the same thing, open the file. In fact, here, return sums, then open the file like that. And then for line to split, number in line. So we need to be careful here. So it's going to be doing this for each line. So what we're going to do is sum, set that equal to 0. I'm going to say for number in line, sum plus equals number. But I should probably do row sum. Okay, and then over here, we're going to do sums that append row sum. And then we return sums, the sums list. So I think this should work. So if we do here, row sums, call row sums, see what we get. If we get a list, run this, and there we go. So in fact, we can just copy this and see if we get the same value from soup calculator on the first row. Yeah, we get negative 1322. Yep, negative 1322. Just do it with the second row. We'll just do it for like the first 3 rows and see if we're accurate. Negative 41, negative 41. The next one will be 417. So let's copy row 3, calculate, and 417. So our function seems to be working pretty good. So let's submit this first solution. Actually, I have to get rid of these, otherwise it's gonna give us an error. And I'm just gonna clean this up just a little bit, add some spacing, make things look a little bit neater. We're gonna make some more updates to this, so don't worry. So let's run our code through these tests. We passed. We can send that solution to the server. So I'm not gonna look at the model solution for this in this instance. What I will do is see how we can clean this up a little bit, because we're seeing a lot of repetitive things being done. For example, each function opens the file. Each function individually, and it goes through the lines individually, right? So maybe we can clean this up again, maybe by creating some helper functions. Okay, so what can we improve here? So we see that each function opens the file, reads the file line by line, splits it, and does something, right? It does some number stuff. So if each function does this, then maybe we can create a helper function that will read the matrix for us and then return that matrix that we can then use to iterate over in our 3 functions here. So let's define a function here called read matrix, right? Just for simplicity. Doesn't take anything and just returns a list. We declare a variable here called matrix, set that equal to an empty list, and then we're going to open the file as we've done a bajillion times here. So I'm just going to copy this. And then do the same thing for a line in file, get the row, and then for a number in line.split, row.append, integer number, and then matrix.append the row, and then return matrix. Like that. So some of the stuff we're actually doing in line, right? So here we're saying for line in file, right? For number in line. So we can actually just do this. We can, split the line as it were here. So for number in line.split, and then, continue on. Anyways, let's continue. So this is our helper function now. So now, instead of doing all of this in here, for example, in the matrix sum function, what we could do is just loop through the what we get returned from the read matrix function. So we can say for row in read matrix, for number in row, total plus equals, not total, sum plus equals number, like that, and then we return sum. So now let's run this. Let's run our code with this new update and see what happens. Oh, right, I'm not printing the print matrix sum function here. What are we going to return? There you go. So it still works, right? Now our function here is a lot smaller because we don't have to handle so much workload inside the functions here. We've extracted some of that labor to this read matrix function. So the same thing goes on here with our matrix max function, right? So that now becomes for row in read matrix for number in row. If number is greater than largest, largest is equal to number, and then return largest, right? So now we've shrunk this down even sum itself. So when we call matrix max, run the code, we still get 965 as the matrix max. And then same thing for row sums, right? So we can go in here and we can say, instead of this, we can just say for row in read matrix, total is equal to 0. And if you notice, I'm not saving what's the matrix being returned, right? I could do this. Matrix is equal to read matrix, and then loop through matrix, right? But Python allows us to do this in line. So Python will run the code, run this function or call this function in line, And now we're just working with whatever's returned from this function call. So that's why we're not assigning it matrix to the function read matrix call. So that's why we're doing it this way, right? Python lets us do this. So here we can say total is equal to 0 for number in row total plus equals number, and then sum dot append total. Sorry, sums dot append total, like that. Just clean this up a little bit. And now when we go down here and get print row sums, like that, I'll clear our terminal here for a little bit of clarity. And there we go. We still get that list. We still get 13, 22, 41, 417. So we know that this is kosher as well. So again, we can delete these. We don't need them anymore, those print statements. We can submit the code as it is, send that solution to the server, and this also works. So again, you might even prefer to make this even more universal, right? Let's say, for example, you want this this program to do anything, right? For example, like, I mean, not anything, but to open different kinds of files. So here we can even pass an argument called file. I'm sorry, I should probably say file to read, right? Like that. I'm not sure what the actual type for file is, but something like this. And then now, instead of passing the string here, I can pass the file to read. So now I can say, hey, I have this function, I have this program that can do this for any file name in the matrix. You just have to call it like this. Just pass the file name to the read matrix function, and then it will work. So you can even do that, but I'm just going to keep it the same, matrix.txt. Again, make sure when we run it, it does work. We're not getting an error, so we know it's working. But yeah, so we've just abstracted a little bit of the labor of opening the file repetitively in each function here, right? For matrix max, matrix sum, and row sums. We've extracted that labor to a dedicated read matrix function. And now that does it for us and just returns us this matrix. We've worked with matrices before, and we know how to loop through them, so that we can just do this. We can just loop through them here casually and then return whatever values that we want after we've done some arithmetic. So yeah, so that's my solution. Again, if you want to, we want to take a look at the model solution in the browser, see what they did. I'll close all these helper. Wow, word for word, bar for bar. They have another helper function here called combine. It's in Finnish, so I don't know what this comment is saying, but again, like, this is again just to even simplify it more, because we know we're going to be working with lists anyways. So this combine function, right, takes a list, and then, right, it loops through our list and then appends those values, each row, to the list, and then returns the list. And then in here, we can get the sum of the returned list. To get the matrix sum, here we can get the maximum value, and then here they're not using it, the combine function, but they're also able to loop through the matrix and get the and append the sum of each row to the sums list. So again, they have here also a read matrix function, just like we did, right? It opens the file, creates a list, loops through the file for each row, and then splits each line, appends it to the nested list, and then it appends that to the main list, and then returns the main list, which is exactly what ours is doing over here. So yeah, as you can see, this is just a way to abstract. This is also a very clever way you can abstract further if you'd like, but I don't think it's really that necessary. But it does help a little bit. You can probably even just use some of these individually. So you can probably combine what's returned from the read matrix, and then from there return the sum, right? So I'm thinking maybe do this: return sum of combine, right? Because combine also calls, no, it does not. It loops through it itself and then gets the read matrix. So I don't know. Well, maybe I'm getting ahead of myself with what I was thinking in my mind. I thought the function combine was also being like it's like a reserved thing. Like there's a list function called combine that we can also use. I'm getting ahead of myself. Maybe I'm too hungry. But yeah, that's the solution for this exercise. Hope you guys liked what we put together. So if we go back over here to the course website, refresh, we got credit for that. So we're about an hour in, and this is where I'm gonna cut off the video. So when we come back in the next video, we're gonna be continuing from here, right? Reading the same file multiple times. We'll do this reading because it's a lot of readings here, and it's a lot of information that we gotta digest. So you can go ahead and go through it yourself and see how you do. And then we have some exercises that come in tandem. 5 exercises actually that come in tandem, and then a little bit of readings, followed by the last exercise of this section. So by the time we get to the final exercise in this section, we'll probably have gone through almost half of all exercises in this chapter, right? Because the city bikes is the last exercise, and that's exercise 9. So we would have gone through, you know, the bulk of the exercises that are available in this entire chapter 6 in just the first section. So probably expect the next couple of sections to only have maybe 3 or 4 exercises per, maybe 2 or 3 per, just so we can to stretch out the remaining number of exercises left. But yeah, we'll see you guys in the next video. We'll continue with the section. I'm actually enjoying this section a lot. I think it's long overdue, and this is one of those things that, again, as I'm comparing it from my experience learning how to program and going through college and getting a degree in this stuff, like even in college, because remember, a typical college semester, at least here in the U.S., is like 15 weeks, right? So you have 15 weeks to get really good or get serviceable. I shouldn't say really good, to get serviceable, right? To know your way around a certain programming language, right? To be able to write functions, work with variables, create classes, work with objects, handle exceptions and errors, and how to open files, how to write to files, how to read files, et cetera, right? So you got to learn that in 15 weeks. So we're lucky that we're just self-pacing ourselves. We started 4 months ago. The first video we posted was 4 months ago. So that's way longer than a college semester. Most college semesters are like, well, that's not true. The spring semester is a little bit longer than the fall semester. That one's usually like 12 weeks long. It's only like from September to December. You only have like 3 months. But the spring semester is a little bit longer. It starts from end of January and it goes all the way till end of May. So it's about 3-4 months ish in length. So that's a little bit longer. But you only have a certain number of weeks, and those weeks fly by quick because you're taking other courses that are also very demanding. So you have to be able to put the time in and the work in to be able to grasp the concepts and the material that you're reading and the theory that you got to read and understand and digest. And it's very, very intense. So for us to be able to just take this course in a vacuum like this and go through the content, I think is really helpful. And I hope I'm delivering some useful information and details and context that kind of helps open your horizons a little bit onto what the material that we're covering is talking about, and how to apply what you just learned. So I'll see you guys in the next video where we will be continuing with section 1. Actually, no, I'm lying. In the next video, we won't be continuing with this, but I do have a surprise for you guys that I want you guys to pay attention to, because it's something that I think could be really helpful for us to get more practice from the content that we're currently learning. So yeah, I got something for y'all. So stay tuned. That will be the next video, and then the video after that will be us continuing section 1 of part 6. So thank you so much for watching. Make sure you give this video a like. Subscribe if you haven't subscribed. If you have any questions about what we've covered so far, if you've had any issues, if you came across any problems, let me know in the comments below, and I'll try my best, to the best of my ability, to help you overcome that issue. If I can't solve that problem, then if both of us with our combined brain power can solve it, I'm sure we can find resources online that could help with whatever issue you might be experiencing. But yeah, this has been an awesome, an absolute joy to be able to do this. So thank you guys so much for trusting me to continue to deliver this content. The solutions from all the exercises that we did today will be linked in the description below on the GitHub repository. Give it a, go check it out. Please give that repository a star. I truly appreciate it. and I'll see you guys in the next video. So thank you so much for tuning in, guys. We're making headway. We after we finish section one, we're gonna breeze past the remaining sections in part six. And again, I have experience with all of these materials here, so it's not going to be anything really new or challenging. And we've gone through the bulk of the exercises in here, so we know that there's only 19. So once we finish section one, we'll be down to only 10 exercises. With 3 sections left, I mean, each section is at most going to have like 3 exercises. Maybe one of them will have 4. So we're gonna breeze past the remaining sections, and we'll be on part 7. And after part 7, where we learn modules and some other built-in features of Python, we'll be done, and we can go and take the exam. If for those who want to go take the exam, you can go take it, and we'll be ready to start the advanced course. I will make another video when we get there. If people do want me to cover the advanced course, somebody already has raised that question, so yeah, if more people want me to do it, we'll go through the advanced course as well. If not, we'll complete the playlist and these walkthroughs after we finish part 7, and I'll make other content about programming. So yeah, I'll see you guys in the next video, where we'll continue and hopefully finish section 1 of part 6.